As we continue to talk about transformations and rigid transformations, we are going to discuss rotations. And in doing this, we want to develop the definition of a translation using constructions. We want to be able to write the rule that describes the given translation, and determine the image or pre-image of a figure after a given translation. So again, rotations are going to be a rigid transformation, and we want to remember that rigid transformation is a transformation that preserves the size, the shape, the length, the lines and angle measures of a figure. And as we get into this rotation, it's rotation in a plane, a transformation in which each point on the figure is turned through a given angle and direction around a given point called the center of rotation, such that the distance between the point and the center of rotation remains fixed. So we're going to, when we talk about rotations, we're going to have a pre-image, we're going to have a new image. It's going to have an angle of rotation, and then that angle of rotation is going to be based on a center of rotation, all maintaining, the rigid transformation of its size, shape, length, lines, angles, etc. So our properties are going to maintain that rigid transformation, but our points are going to be rotated a given direction, either clockwise or counterclockwise. So when we are rotating clockwise, that is going to be a negative rotation, and when we are rotating counterclockwise, that is going to be a positive rotation. And then those are really some of the two big things to think about in our properties as we continue with this. And of course, they will all have that center of rotation that we talked about. So looking here is this example. It says, show the rotation of a rectangle ABCD after a rotation. And my rotation is showing that my rotation is going to be X, Y, are mapped to negative Y, X. So if we can do this, let's turn around and say, okay, well, if I look at point A here, point A is going to be ordered pair -2, 0. So A of -2, 0 maps to, so I want to take my Y value and make it my X value and make it negative. So that would be -0. Right, because that was my Y value, and I'm placing it here. My X value is going to remain the same, which is going to be -2 in my Y position. So what I've done is I've taken my X, -2, and I've put it into my Y. I've taken my Y, made it a negative, and put it into my X. And I will just remind everybody that 0 is neither positive nor negative, so I'm going to go ahead and remove that, and it's just going to be 0. So my A prime is now going to be 0, -2, which is going to be 0.0, -2. And I can do that with all of my points now. So as we map these out, looking at B, my B is going, I need to probably lower that a little bit. B is going to be -1, 0, and it is going to map to B prime of something. Then we're going to have C. C is going to be -1, 4, and it is going to map to C prime. And then D is going to be -2, 4, and it is going to map to D prime. And again, so I'm following my mapping guides. Okay, so my mapping guides, my X value is going to be the -Y value. So when I come down here and I look at my B prime X is going to be the -Y, which is going to be 0. C prime X value is going to be the -Y, so Y is 4, so that's going to be -4. And then my D prime, again, is also going to be, the new X value is going to be -4. When I go to look at my Y values, okay, so my Y values in my my rotation is going to be y is going to be my x value. So I'm going to take my x value and I'm going to make it my new y value. So there we have, I've come up with some ordered pairs, and if I graph these, of course, we've already graphed A. This is A prime. B prime is going to be 0, -1. C prime is going to be -1, -4, and then that is C prime, and then D prime is going to be -2, -4, or -4, -2, sorry. So there's my new translated, rotated rectangle ABCD with my new values. All right, so looking at these rules of rotation. So if I'm going to rotate an object 90 degrees, rotating an object 90 degrees, my mapping rule would be right here. So, which is what we just mapped. We just mapped a 90-degree mapping rule where my new x value is the old negative y value. My new y value is the old x value. So if I go in here and I want to do this mapping, so as we look at our rules for rotation for 90 degrees, and again, coming up with these new points, so I'm going to go ahead and set up the rule here, and I going to map xy is going to map to for a 90-degree rotation. So we're going to be mapping counterclockwise 90 degrees, and so it's going to be my x value, my new x value is going to be the opposite y, and my new y value is going to be the x value. So as I map, let's go ahead and label these points. A looks like if I have an ordered pair for A, it is going to be 1, 2, 3, -5, 3. So I have -5, 3. B is going to be B, or we're looking at, I want to say -2, 4, and then C is going to be the ordered pair of -2, 2. Okay, so as I go ahead and I do this transformation or this mapping, I'm going to have A is going to be -5, 3, and it is going to map to, okay, so it looks like my new x value is going to be -y. So if my old y value is 3, my new x value is going to be -3. And then my new y value is going to be x, which is going to be -5. Again, so B is going to be, oh, let me fill some stuff in here, sorry. Let me fix that. Let's do this, right? Let me get that B prime in there, or A prime in there, so we know what it is. It's going to map to A prime. It's going to map to B prime. So the old B value is going to be -2, 4, and then my new mapping to B prime. Again, my x value is going to be the -y, and that is going to be -4, and then my new y value is going to be my old x value. So I have -2, and then I'm going to have C, which was, we said, -2, 2, and that is going to map to C prime, which is going to be the negative y value would be -2, -2. Okay, so as we go to graph these, let's graph our new points. So we have A prime is going to be -3, -5. So I'm looking at -3, -5. And that is going to be A prime. B prime is going to be -4, -2. So -4, -2. Sorry, I don't need to do all that. I just need to make sure I identify it as B prime. And then C prime is going to be -2, -2. And if I go ahead and do my connecting of the dots, it looks like I have that same figure has been rotated 90 degrees. So again, just doing some substitution there. If we look at it at 180 degrees, right? So 180 degrees is going to end up putting it somewhere over there. That would be 180 degrees away from it on the coordinate plane. And in doing so, we're going to do the same sort of mapping that we have now. It's just if you see the mapping rule, when we rotate 180 degrees, xy is going to map to negative x, negative y. So that seems a little bit more easy for us to have to contend with. So what points did we come up with? We said that A was going to be, and I'm cheating here, right? Negative 5, 3. B was negative 2, 4. And of course I could just look at the graph and see it because I'm using the same image, but you know, why not do this? All right, so as we map, we're going to map to A prime, and my signs, the only thing that's happened here is just my signs have become opposites. So negative 5 becomes 5, positive 3 becomes negative 3. And if I go ahead and 5, negative 3, B prime is going to be a positive 2 and a negative 4. So B prime is going to be a positive 2, negative 4. That was A prime, B prime, B prime. And then C prime is going to be the opposite again, which would be a 2, negative 2. And that's going to be C prime, and when I connect that, I have the new image. And if that is difficult to see, the new image, which is going to be C prime, B prime, A prime. So that is 180 rotation. And I know this may seem foolish, but a positive 180 or a negative 180 rotation is going to end up in the same location. And let's see here. I'm going to copy some stuff real quick. Now, as we work on a rotation of 270, it looks like our x values is going to map to y, and our y value is going to map to negative x. So that means that when I have A prime x value is going to be the old y value. So the old y value was 3. And then the new y value is going to be negative x. Well, I had negative 5, so opposite of that would be 5. And then my B prime is going to, again, the new x value is my old y, which is 4, and then the new y value is negative x, which is negative x, which is going to be not a negative 2, but a positive 2. And then my C prime is going to map, again, my y value and my opposite x value. So if we go ahead and graph these, let's see here, A prime is going to be 3, 5. That's A prime. B prime is going to be 4, 2. And C prime is going to be 2, 2. 2, 2. But anyway, there we go. It looks like this is a mapping in a positive 270 degrees. And you may think, too, that 270 degrees positive is the same thing as negative 90 degrees. So just an observation. Again, like I said a minute ago, a positive 180 is the same as a negative 180. And then your positive 90 rotation is the same thing as a negative 270 rotation. So just sort of tying those kind of rotations in together. So rotation rules, remembering the rules, being able to do the substitutions. Now going here, it says we have this triangle. So here's an example, right? Nothing better than a good example. It says the triangle ABC was rotated about the origin. Which rule describes the rotation? Well, I can tell you that it looks like we started here, these points right here, and we rotated this direction, which is a positive direction. And if I wasn't able to look at that real quick and say 90, okay, let's look at my rules, or let's look at my point. It looks like if I take point A is 1, 4, and it maps to A prime, which is going to be -4, 1. So it looks like my xy has mapped to, it looks like this is -y, right? Because my new x value is my opposite of the y value, and then it looks like that is my rule because my x value became my y value. And I think, and I do believe that that was the rotation of 90 degrees was when x, y mapped to a -y, -yx. So I could see it. I couldn't guarantee it, but I can see it, and then when I plugged in those numbers, I was able to see that rotation. All right, so this example, a triangle has vertices at R1, 1, S is going, and T, okay? The triangle is transformed according to the rule of 270. What are the coordinates of RST? Okay, well, 270. You may recall this from a previous slide. Here's my rule for 270 degrees rotation. So when we're doing our mapping, my xy maps to y -x, okay? So when I take point R, and that is 1, 1, it is going to map to R prime, which is going to be my y value, 1, -1. So I'm just doing my substitution. So I have S, which is going to be -2, 4, and it is going to map to S prime of my x value is going to be my old y value, and then my y value is going to be the opposite of my x value. And then T is going to map to T prime, and that is going to be my new x value is my old y value, and my new y value is opposite my x value. Now, if I were to graph those, I would be expecting them to go as a 270. That is a positive rotation, and I would expect it to rotate this direction, right? Rotating this direction is a positive rotation. And if I start off with RST, so R is going to be 1, 1. S is going to be -2, 4. And T is going to be -3, 3. -3, -3, sorry. Right there. So that is what that looks like. And then when I go to do my rotation, goodness, I hope this works out. And I guess I should R, S, T. Go to do my rotation. R prime, right? Let's look for R prime. R prime is going to be graphed at 1, -1. So that is going to be 1, -1. S prime is going to be, that's R prime. S prime is going to be 4, 2, 1, 2, 3, 4, 1, 2. And then T prime is going to be -3, 3. 1, 2, 3, 1, 2, 3, something like that. So we have our transformation. Let's see, well, my measurements aren't identical, but could that have been the correct transformation? Let's see. Yeah, I think that looks right. So we have a rotation. Again, not drawn to scale. My marks aren't perfect, but making sure that I did identify some of my marks on here, my increments. And so it looks like S should have rotated 270 degrees. Again, I can do it with a table and mapping, or I can, see it, verify it on a graph. And just to summarize some key points, remember that rotations are these rigid transformations, and they keep all of the same characteristics of the original image. There is a center of rotation which does not change position, in which case my center of rotation was my origin. And then the angle of rotation counterclockwise is positive, right? This way is positive, and then negative clockwise. And then segments connecting corresponding vertices are going to the center of rotation are going to be congruent. That orientation isn't preserved like it was. It is rotated about the center of rotation. And remembering those rules of rotation, if you have these memorized, rules of rotation are very easy. If you can't remember the rules, if you can't memorize these, I wouldn't stress too much, because you can easily put something on a graph and see how things rotate.